Hello guys, welcome to my science fair project. Okay, here's the problem folks. I don't know what type of reaction these three reactions are. Are they physical reactions or are they chemical reactions? So today, I'm going to be preparing a test for y'all where I'll be testing the three different reactions to see what type of reaction they are. So without further ado, let's get started with Coke and Mentos. Okay, this is the Coke Science Fair experiment. Hopefully I don't end up like everyone else who's done this before me. Let's get started. All right, we're gonna pour it in. As you can see, it's completely foaming out. And that has a lot to do with the carbon dioxide, but we're gonna get more into that in the next part. From what you can see in the experiment, foam came out of the bottle. To explain this, you need to look at one very specific thing found in Diet Coke. CO2. The CO2 is what the carbonation in the drink is. The reason why I brought up CO2 is because Mentos has this rough surface, I guess you could say. And since these surfaces are very rough, they have small little air pockets in the middle. So in turn, the CO2 rushes into the air pockets. However, this causes the rest of the CO2 in the bottle to rush. So all of it just bursts straight out the bottle. However, you can also notice in this experiment, no new substance is created since only CO2 is rushing out the bottle. So this means this experiment is a physical change. Alright, next up we have the baking soda and vinegar experiment. When baking soda and vinegar react, there's actually two reactions that happen. So the first reaction happens and two chemicals are created, carbonic acid and sodium lactate. This first reaction has nothing to do with the bubbles you see. The second reaction is known as a decomposite reaction, or decomposition. I can't say it right, but we'll just keep going. That happens when the carbonic acid interacts with the water that is in the first reaction. Once that happens, it quickly turns into carbon dioxide, which is the bubbles you end up seeing because they rise to escape, similar to the Coca-Cola and Mentos experiment we just did. However, since these both reactions created new substances, this is a chemical reaction. All right, now we're gonna do nice and slow close-up reaction. A little bit heavy on that first part, but you can see it interacts and then expands immediately. Its carbonic acid is created and then it quickly deforms into carbon dioxide. If you wanted to see what it looks like without the detergent, you can see right here. It's mostly similar. That one gives it a bit more bubbles. And it foams up, the foam stays. See, this dissolves like that. Like, look, you can still see the other one over there. It's all still bubbled up. Alright, so now we have elephant toothpaste. This one's gonna be probably the craziest one we've had. Alright, so here it is, the ingredients to make elephant toothpaste. So first things first, we have our hydrogen peroxide, our yeast, some dishwashing soap, and food coloring. So the thing about all these, especially hydrogen peroxide is very unstable. It pretty much slowly dissipates over time. So eventually, in this bottle, once the expiration date is reached, you'll just have water in there and maybe a bit of oxygen. So first things first, what we're gonna do is pour this there. Nice and slow. Did it with a funnel just to make sure. Get everything right. You also put dishwashing soap in for the same reason we did that for the baking soda and vinegar experiment. Because it sort of bubbles up the reaction a lot more. Put that in there. Food coloring is just for fun, you know? So the thing about elephant toothpaste is, since it slowly dissipates over time, the yeast that we have right over here, which is also known as potassium iodide, pretty much speeds up that process in a matter of seconds. So what could take years takes seconds here with elephant toothpaste, which is why we're going to use this yeast to start the experiment. Alright guys, now we are going to pour it in. Alright, just watch this very slow. Oh, look at that right there. I mean, so, as you can notice right now, this is giving off heat. I don't know if you guys can see it, but there is smoke rising from this right now. It's also creating more and more bubbles, which, you know, some classic CO2 action. But this is just the rapid dissolve into oxygen you usually see with, because this happens very slowly over time, but all the oxygen, boom, just came out of nowhere. Same thing with H2O. So, think about it. This thing changed in heat, and it also produced oxygen. You know what I think that is, folks? A chemical change.